Hello everyone, welcome to this video. In this video, we are going to learn the probability of dependent events using an example. Here is the example. With one method of procedure called acceptance sampling, a sample of item is randomly selected without replacement, and the entire batch is accepted if every item in the sample is okay. So if there is a batch of the manufacturer's item, and if we want to test for acceptance, what we do is we select a couple of items, and if all of them are non-defective, then we accept the entire batch. The process is called the acceptance sampling. And here is the example based on that. An electronic company has just manufactured 1,350 flash drives, and 120 of them are defective. If 3 of these are randomly selected for testing, what is the probability that the entire batch will be accepted? So here, the total number of flash drive manufactured are 1,350. And out of these 1,350, 120 are defective. So total number of flash drive manufactured are 1,350. and 120 are defective. Now, if we want to find the non-defective, so non-defective will be, let me write here, non-defective will be 1,350 minus 120, which is equal to 1,230. That means out of the entire batch of 1,350 flash drive, 1,230 are non-defective. Now, what we are asked to do is if 3 of these are randomly selected. So you are picking the first one, you are testing whether it is defective or not. You are not putting that back. Then you are pulling the second one and testing. And then you are pulling the third one and testing. If all these 3 are non-defective, then the entire batch will be accepted. So the question is, if 3 of these are randomly selected for testing, what is the probability that the entire batch will be accepted? And we have to give our answer to 4 decimal places. So what we are looking for is, we are looking for probability that all 3 are non-defective. All 3 are non-defective. The first is non-defective, second is non-defective, and third is non-defective. So because it involves and, this is the multiplication rule. So this is same as probability that the first is non-defective multiplied to probability that the second is non-defective times the probability that the third is non-defective. So that is equal to, so here the probability that the first is non-defective out of 1,350, out of a total of 1,350, 1,230 are non-defective. 1,230 are non-defective. So the probability that the first selected flash drive is non-defective is 1,230 over 1,350. Now, we are not replacing the first drive back. So the probability of the second will depend on the first. So now, the total number of flash drive remaining is 1,349. So out of these 1,349, one of the non-defective flash drive is taken out here. So the remaining will be 1,229. 1,229. So the probability that the second flash drive is non-defective is 1,229 over 1,340. And we have seen that the probability of the second depends on the first because the first one is not replaced. So the first one is tested, second one is tested. So these 2 are non-defective. Now we have to find the probability that the third one is non-defective. Now the probability of the third one depends on first two because we are not replacing these two. So the total number of flash drive remaining is 1348. Two non-defective flash drives are already taken out. So the remaining non-defective flash drives are 1228. So the probability that the third one is non-defective is 1228 out of 1348. So these are the probabilities that each of these will be non-defective. So now if we multiply the result using calculator, it is 0.7562. So that is the probability that the entire batch will be selected or the entire batch will be accepted. So here what we have done is because we are looking at three of these flash drives and all of them must be non-defective for the entire batch to be accepted, we find the probability of each. And we saw that when we find the probability of the first and try to calculate the probability of second, we saw that the probability of the second depends on the first. And similarly, the third one, when you calculate the probability that the third one is non-defective depends on first two. The reason is we are not replacing the first two. So this is the example of multiplication rule of probability based on the dependent events. I hope you find this video helpful. Thank you so much for watching.